Good morning, ladies and gentlemen. Thank you for participating to this the training. My name is Simba, and I am a aero solution manager from work from DJI. And thank you for your time to participate today's the webinar. And today we're going to cover the DJI enterprise solution for aero surveying. So please allow me to introduce our partner, local partner in the UK region. And James Pig is a business development manager for survey and map the constructions from the copters. And if you guys have any the interest of buying our products, you can feel free to contact the copters, and they're a very professional company as well. And that's the the basic history of the copters, and that's the partners. From the partner with the copters. So move to today's topic. We all know that from the campus instrument tape to total station and RTK, satellite and surveying and mapping industry is always driven by the technologies, but to achieve high level accuracy of surveying and mapping mission, it's still time consuming and expensive. We think it's about time to change, just like back to the old days when we first to have a total station RTKs. How those products changed our workflow and quickly became must-have instruments for surveying industry. And now we believe the next big change is there. And I hope every one of us that sit in this conference room can catch this trend, and we together to speed up the change and together to train and educate all the surveyors and end users to get familiar with new technologies. As we all know that surveying and mapping is the technology-intensive industry, and the development of the surveying mapping relies heavily on technology and instrument. So UAV technologies could have a significant impact on surveying and mapping industries. Through this trend, DJI would love to use our UAV technologies to make the surveying and mapping workflow a lot easier and affordable. From experts to every one of us, it's not necessary to know all the tricks of the surveying and mapping, but every one of us could become a surveyor. The trend that we believe that will happen is for our product is one is it will become more affordable, and product needs to be very easy to use. And we all know that efficiency is actually the key for surveying and mapping. So that will be increased dramatically to the next level comparing with the traditional ground measurements. So please allow me to introduce our first core surveying solution, P4RTK plus DJI Terra. And there are several major scenarios that we believe that will perfectly fit for the solution. And of course, there are always more applications that could fit into the solutions. For example, like construction supervision, emergency mapping services, Asian building modeling, road, river, and power line corridor inspection, traditional aerial surveying and mapping, stockpile measurement and close-range photogrammetry, multispectral analysis for smart farming, and environmental protections. Move to the next slide. This page basically tells us why P4RTK is a good enough drone that could perfectly fit for the surveying and mapping missions with our GCPs. Because its durable flight performance and RTK provides precision mapping mission. Sophisticated design and individual camera calibrations combined with the RTK technologies result most accurate map, and PPK, DRTK 2.0, and N-trip support provides rich working method that user can actually choose based on their needs. So from this page, we can see that this is all-in-one, like mature solutions with a camera and RTKs. Also, the GSR app, which is just default flight control apps to control the P4 RTK, also gave them more abilities and comprehensive mission planning method to work around with this drone. And because of the mechanical shutters, and also the time sync technologies, and RTK and PPKs, that when all the things come together, that makes this drone perfectly for surveying mapping job. So one of the accessories for the P4RTK is the DRTK 2.0 base stations, which support GPS, GLONASS, Betel, and Galileo for navigation systems. And the OcuSync 2.0 is DJI unique, real-time transmission systems that could, the distance could up to 7 kilometers, and it supports several DJI aircrafts to link with the single RDRTK 2.0 simultaneously, and it's IP65 rated. And the options that to work around with the Phantom 4RTK, actually there are 4 ways to operate it. First is the NAT RTK. So in the GSR apps, and there is the option that you can actually enter an N-trip account. So at every country that we know that there is the core station that owned by the government, or there are the core station that owned by the private companies. They can log into the account and fly the drones, to perform the precision map missions. And also the software is DJI Terra. As once we capturing all the data from the P4RTK, you can import the data to the DJI Terra, and it can do the post processing for the 2D and 3D missions. The second option is the DRTK 2.0. The DRTK 2.0, it's the base stations that run by the DJI, and that's like when you can use the DRTK 2.0 to work at the area that there's no net coverage, and simply link the DRTK 2.0 to our remote controllers and enter coordinates into the GSR apps. It will set up the real-time RTK connections between the DRTK 2.0 and our remote controllers and the aircrafts to perform the RTK functions. So in this way, there is no need the net coverage, means that you can work anywhere you want if you know the position where to put the DRTK 2.0. And third method is people always asking us, hey, we already have the third party RTKs. Can we use our own RTKs instead of the DRT 2.0? Well, the simple answer is no. But there is a way to work around. You can set your third party RTK as the base station, and you set up your own server, and you create your own N-trip account. Then it can refer to the option 1. You can log into your N-trip account through the NAT RTKs to work around with the third party base stations. And the last option is the PPKs. And DJI, we actually announced our cloud PPK service, recently, and that's actually available, in global region, not include North America, Hong Kong, and Macau. But the cloud PPK for DJI is a unique way, because we set up our server in Frankfurt in Germany, and all the data, the data from the DRTK 2.0 when it performed the mission planning, it can automatically to generate the infomercial data, also the satellite observation files and timestamp file as well. And you simply need to upload those data to the server through the GSR app, and also get the same data from the DRTK 2.0, the RANX data from third-party base station, and import it into the GSR app, and it will upload to the server. So what you need to do is wait for the server to calculate, and several minutes later, and it will generate high precision post data. So by having that data, you can import that data with your images together to software, and DJI Terra will perform the PPK processing for, the image processing by using PPK, by high precision post data. So there are several ways to work around the P4RTK, and this is the mission planning panel that has in the P4RTK. And there are several ways to work with P4RTK: 2D photogrammetry, 3D photogrammetry, and waypoint mission, linear flight mission, and 3D photogrammetry multi-oriented, terrain awareness mode, block segmentations, work with handheld RTKs. So the 2D photogrammetry is one of the early functions that we have, and it's the most common one. Simply at a screen, you use your finger to tap an area, and the GSR app will automatically, based on the area that you generate, to intelligently to generate a flat path for you. Then you can fly the area based on your needs, and you can set the height, you can adjust the speed, and also the camera mode for time shooting, and also camera settings. You can adjust the shutter speed and the exposure rate and etc. And linear flight mission is another 2D mission, that is like typically specifically designed for corridor mapping, roads and river, and for such the 2D missions. Because comparing with the previous method, this way is more designed for the linear type of mission that will greatly increase the efficiency when we're working around for such a linear mission job. And settings are the same. And terrain awareness mode means it is the terrain follow functions. So what it does is sometimes, surveying and mapping is the very, accuracy, focused industry, right? So sometimes if we work in that area that has the huge like fluctuation change on the hills, on mountains, so if our drone always fly at the same level, and it won't capturing the GST at the same level. So, but we need to make sure, when we perform the map job, the map missions, the GST always on the same level. And also we need to make sure that, then that can actually promise the results, right? So we can simply insert the DSM data, but it needs to be under WGS84, geographical coordinate systems, and also has the TFW associated with it, and insert that data into the GSR apps. And when you open the terrain awareness mode, and it will automatically detect the DSM data. And when you plan a mission in the DSM, under the DSM data area, and you can, plan your missions, and the mission will based on the DSM data to perform the terrain follow functions. And another thing that we have is actually the 3D photogrammetry double grilled, and also the 3D photogrammetry multi-oriented. So those two methods are designed for you when you're capturing the 3D models. The difference is when you are at the double grilled mission type, that will capturing the 3D models, and by oblique ways. There is no just the P4RTK will fly the area just one time, and and the camera will always have be oblique to capturing the data. So this way is more designed for if you need a data that is not at very high data qualities and don't really care about the precisions. And multi-oriented actually designed for more sophisticated and more detailed and precision mappings. So that means that drone will fly the area 5 times. The first time, drone will just change the camera angle needed to the ground, and other 4 times, the drone will perform the oblique missions to capturing the area in different angle. So in this way, it will you can actually set your camera angles to 45 degrees because it has the one is nearer to the ground, and you can have more detail on the side of the building as well. And mobile station functions, that function is designed for the connection between the remote controllers and the DRTK 2.0 base stations. So by having this function, there is no need to use P4RTK. The only thing that you need is the base station, which is DRTK 2.0 and your remote controllers. Simply link the DRTK 2.0 with the remote controllers, and you can use the DRTK 2.0 just like any third-party base stations and RTK or GNSS receivers to measure the coordinates. And there are 2 ways to measure it. One is current coordinate, means that I will just do the measurement one time. And another way is that there is the average coordinate values. I will take the measurements, several measurements, and take an average. Means that that number is more reliable. This video shows that another function called block segmentations and multi-UAV controls. So people always complain that our aircraft cannot do a big job because the P4RTK is too small. But the way we solve it is one remote controllers can link up to 5 Phantom RTKs, and by having the block segmentation functions, that we can actually split a big mission area to several small mission areas. Then we can assign each individual P4RTKs to those small blocks to work simultaneously. And next function is the DJI Cloud PPK. Like I mentioned earlier, it's a cloud-based service. And sorry, now it's not only just China and Europe, it's actually global available, exclusive North America, Hong Kong, and Macau. It's easy to use and not like traditional methods, it's cloud-based functions. And we have our server located in Frankfurt, Germany. And the simple workflow that customer only needs to upload the data, the PPK related data, for example, like satellite observation files and timestamp files from the drone, and also from the DRTQ 2.0 or any other third-party base stations to the server. And the only thing you need to do is upload, wait, and download the results. That's it. So once you have the high precision post data, it will be saved as Excel format. Simply save that into your mission folder. And DJI Terra will, when importing the images from the mission folder, it will automatically detect your post data and will ask you if you want to process data by the PPK way. Very simple and easy. And also support third-party RunX data from any GNSS receiver that can generate standardized RunX data as well. So there is not really necessary to use our DRTK 2.0. So next product that we have is P4 multispectral. It's the same base, same flat platforms, just like the P4 RTKs. And it has the RTK modules and same in the motors, performance just like P4 RTKs. But on the top of the RTK module, it has the sunshine sensor, which can receive the solar irradiance intensity in real time. So previously, when people work at the multispectral data, they always need to do the camera pre-calibrations before the drone take off. But now there is no need. Because of the sunlight sensor can receive the solar irradiance intensity in the real time, it will save the composition numbers in the images. When importing those images to DJI Terra will, based on those numbers, do the compositions and make sure that the camera is always at the best shape. So, again, it's also supported the RTK 2.0 and entry per count and OcuSync centimeter level accuracy, just like the P4 RTK. And the default app is GS Pro, which is iOS-based software. So the P4 multispectral has the 6 sensors on it. 1 RGB and other 5 are red, green, blue, near infrared, and red edge, and all at 2 megapixels, and with the global shutter on it. And we all know that for the vegetation indexes that the healthy vegetations will absorb more on visible red and reflect more on near infrared. So that's why the red and near infrared and red edge are the indicator for sometimes the healthiness of the vegetation, and especially the NDVI is one of the key. So another very powerful and unique functions for the P4M is you can actually in GS Pro display the real-time NDVI index. So while the drone was flying. So that means that, if the farmers and some, researchers, they want to do some quick actions on the crops, on their, vegetations, when the drone was flying and the real-time NDVI can quickly tell them that where has the problem. They can go there and take an action, and there is no need to send the data back home and to process it and, analysis it and come back to the field again. But if you want to use DJI Terra to do the post-processing of the vegetation indexes, make sure that while the drone was flying, do not use the NDVI view, turn back to the RGB view, because it needs to capture in the RGB images to reconstruct the DSM data first. The DRTK 2.0 for the precision, centimeter level, and also the net RTK, just like the P4 RTK, it's the same. So move to DJI Terra. So DJI Terra is the PC application that integrates autonomous route planning, aerial photography, 2D and 3D model reconstructions, and model measurements. And all-in-one solutions help industry users to improve the efficiency of internal and external workflow and make the work a lot easier. And there are 4 core functions that DJI Terra has. One is intelligent route planning. So that will generate, the missions. Just like the GSR, you can plan a mission in DJI Terra because it has the bigger screen. It's a PC-based software, so you can generate more complex and sophisticated missions in the bigger screen a lot easier. And also another advantage in perform a mission planning in DJI Terra is that actually gives the abilities to perform the real-time 2D map and also the real-time 3D point cloud data while the drone was flying. So that's the 2 core functions for data capturing. And the posterized, we can generate the high resolution and high quality 2D to also mosaic images, and also the 3D models and 3D point cloud data as well. And that is actually designed, for the precision reconstructions. And DJI Terra actually has the best efficiency when they work with the DJI aircraft. So, and also, the DJI Terra is have the abilities to support P4 multispectral as well. It can generate the several vegetation indexes, for example, like NDVI. And we know that NDVI actually have a range from 1 to -1. So with a number approach to the +1, that means the vegetation is more, it means that houseness is more healthy, and the intensity of vegetation is more intense. But when the number is towards the -1, that means the area is more like a barren soil, like concrete, stuff like that. So that's the great indicator for the healthiness of the vegetation and the cover of the vegetations. And we can achieve all of those functions in DJI Terra. So this video is quickly tells you that from assembling a drone and connect to DJI Terra and let the drone fly, and while the drone is flying, it will generate the real-time 2D map. And when the drone landed on the ground, we already got true digital also mosaic images on the side. So that's a great tool for the emergency mapping. And from this video, we can clearly see how fast it could be. So now it said that the 2D map is being processing, and when the drone land on the ground, we already get the data that we need. And this is another example of the real-time 3D point cloud generation. And this case, that tells you that efficiency, while the drone was flying, that we can capture the point cloud data on the side. And this function needs the, if we want to just have a real-time 2D map, there is basically no need for the hardware configuration of the laptop. Basically, any laptops are fine. But if we're looking at 3D point cloud generations and post-processing of the data, we need a laptop that has at least 1050 Ti NVIDIA graphic card, and with the 16 gigabyte RAM at least. And this is another example of showing the measurement tools of the DJI from DJI Terra. When we have the 3D models and 2D map and point cloud data, we can do the measurements of the coordinates and distance and area and volume. And also on the models, we can click on any locations that we need, and we turn on the camera poses, and it will pops up all the images that for these locations, and we can do the photo inspection as well. So in DJI Terra, that also, we can do the measurements and we can check the accuracy as well. So it supports the coordinate system transformation. So it can convert the coordinates from your map and models into over like 8,500 plus major coordinate system by your needs. And also the GCP support that, well, like as we promised, if you use the P4RTK and there is no need to perform, the ground control points, you can use all the checkpoints as the checkpoints, to measure the accuracy. But if you use the data from the P4 Pro, then you can actually set the several ground control points to adjust the accuracy, then set several control points as the checkpoints to measure the accuracy. And quality reports tells you that how accurate your project is, and also tells you, give you overall and brief view of the, true digital also mosaic images, and also the DSM, and, overview of those data. And also it will shows you the calibrated and utilize the camera parameters as well. So those are some examples shows the efficiency of DJI Terra by looking at the quantity of different numbers of the, we take on the DJI Terra process. Those images are at very, very fast level, and we can see it at least double compared with our any other third party like photogrammetry software. And we see that the computer configuration is actually just the average level. And that's a great tool for the quick and emergency response and disaster assessment. And this is another example of the DJI Terra, and it's the quick, this is like one of the car accident things that we use the DJI Terra to process to create a 3D models, and data were captured by Phantom 4RTK. We can even clearly see the plate number of the car. And this is another example of the real-time, the 2D map. And this is one of the areas that have been damaged by the hurricane. And we quickly send our drones to fly the data and capturing the real-time 2D map on site. Before the drone land on the ground, we already got the data that we need. So, and this is another example of the real-time point cloud data generations. So simply plan a mission, and DJI Terra will intelligently generate a flat path, and based on the flat path, while the drone was flying, it will generate the real-time point cloud data while the drone was flying. So this way we actually perform oblique missions. The drone will fly the area 5 times, and every single time, it will create some point cloud data by every single missions that you have. And those are some example. Those point cloud data are not posterized processed. Those are all the real-time point cloud data. We can see the quality of those point cloud data. And those are some examples of the the true digital also mosaic images are generated by DJI Terra. We can see the cracks of the top roofs, and it's basically just like the real. There's no distortions basically. And another example of the bigger like thing 3D models, and that shows you the efficiency over like almost like 1,000 images, and for 3D models only take around like 6 hours. The computer is not that powerful, actually. It's just an average laptop that we have. And comparing with other softwares, we're at least a double speed comparing with any other third-party software. And this is another example of the Asian building modelings. That shows your efficiency, and also for some irregular shape of the buildings, the quality of the reconstructions that we can have. And this is an example of the accuracy, shows you the accuracy. And we use the P4RTK to fly the area, and there's no ground control points. All the points are used as checkpoints. So when we look at the average, like the accuracy, we're saying that all the accuracy are within 5 centimeters with no GCP. And on the 3D models, when we measure the accuracy, it's the same. All the accuracy for horizontal and vertical are both within 5 centimeters. And also in DJI Terra, we can measure, like I mentioned before, we can do the point, which is coordinate, distance, and area, and volume measurements. And we can do cut and fill measurements for the mining, stack piles measurements in DJI Terra as well. And those are some examples of the products that were being created by DJI Terra. And another thing is what right now is the 5G is a big deal around the world. And when the telecommunication company they construct and build the 5G panels, that they need to do the inspections for those telecommunication towers. And in those towers, all the lines are kind of cross each other, and some lines could be so tiny. And for those type of the buildings, could be very, very hard to generate by from photogrammetry perspectives, but we can see the results from DJI Terra. They almost look like real. And this is another example of for the Asian building modeling. And this is the site mapping. We fly the drone P4RTK towards the side of the mountains, and we can see the temple that are being generated by DJI Terra. And we can even see the inner buildings and how it looks like. And this is another example of the construction supervision. We deployed our DJI P4RTK periodically to fly like our 3D constructions. And this is our new headquarters called Sky Cities. And we use our drone to fly this area periodically to check the construction progress, and simply import data to DJI Terra and to check the building progress. And this is another example of the multispectral analysis. Simply, we can run those vegetation indexes in DJI Terra, and it will tell you, the stats of the different, indexes. And this is super fast as well compared with any third-party software. And so those are the applications that we could apply for P4RTK and DJI Terra, like Asian building modeling and cell tower inspections and city modeling, surveying, and digital agriculture and property management and constructions, even a small thing modeling. So next products that we can mention is M600 Pro and the GS Pro. So that one is actually designed for a large area, large payloads, for example, like LiDAR and more like a rich pixel, like cameras, like Phase 1, something like that. And also for DJI own products like the Hasselblad A60 and the default APP is GS Pro. We can do the intelligent mission planning as well. So by one of the DJI solution we have is M600 Pro plus Hasselblad A60. So that is the perfect tool because the 100 megapixel camera, it has abilities to do the inspection for the millimeter cracks, for example, like in the bridge inspections and dam inspections. And also it's a great tool for large scale mappings because of the pixel that like Hasselblad A60 can provide. And RTK can reduce the GCP need for when operating the work. And this is some case study example that are created by the Hasselblad A60 and 3D models are being generated by this camera. And also people use M600 Pro to carry third-party solutions like oblique cameras and LiDAR because this drone is safe enough. The system domain that actually capturing give you the more abilities in safety operations, for example, like dual and triple like GPS antennas and IMUs and batteries. So that all greatly improve as a backup systems, greatly improve the safety while the drone was flying. That's why people can use this drone to carry a very expensive sensor to do the mission. And those are some example and showcase from DJI from the M600 Pro, and it's a great tool for city renovation, cadastral management, and public security, and smart city emergency rescue, city planning, and terrestrial map planning and constructions. And those are some showcase from the M600 Pro with oblique cameras. And those are some showcase from M600 Pro with the LiDAR sensors. You can do some like structural inspections and forestry analysis, and also the stockpile measurements as well. And so those are some results in the true color point cloud data that will be captured by third-party LiDAR system with the camera from the M600 Pro. So another core products that we have is M200 series. So again, that's the tool for design for construction supervision and close range photogrammetry, stockpile measurement, and roads and river, power line corridor inspections, and traditional surveying and mapping, vegetation analysis, and city modelings. So this aircraft is, first of all, it's the open platform. Based on the PSDK, you can actually deploy different sensor based on your needs. And the dual antenna settings and RTK settings are actually increase the flexibilities and durabilities to work at a very complex environmental. For example, like area has the strong like magnetic interfere like near the power lines, near the city areas. Because the dual antenna, they will also always knows the position of the two antennas. To the point that we can draw a line, and we can have another line which is perpendicular to those lines. So that drone, will always know the direction of where it needs to be fly. And that's one of the reasons that even the campus doesn't work, this drone can still work at such an environment. So the one of the precision mapping solution that DJI offers is Matrice M210 RTK V2 plus X7 camera equipped with 24 or the Matrice M210 RTK equipped with the X7 camera with 24 and 35 lenses that can achieve precision mapping. So that's the solution provided by DJI as well. So, compared with the the P4 RTK, there are several advantages of the Matrice M210 RTK V2 with X7 camera of 24 and 35 millimeter lenses. One is because of the longer lens, so that Matrice M210 RTK V2 with X7 camera with those two lenses can fly a lot higher to have a same GSD. So that actually increased the flexibilities to work at the city area, because sometimes there are some high buildings. So for example, like for the P4RTK, if they want to have like 1 centimeter GSD, that the P4RTK needs to fly around like 37 meters. But for matrice M210RTK, based on the different lenses, you can fly either 61 meters or 98 meters, 89 meters. So that will greatly improve the working capacity, and also the dual antenna settings, and the waterproof level of the matrice M210RTK. That also increased the abilities to work at complex environment. And another thing is for the matrice M210RTK is the open the PSDK program that equipped with different sensors. So you can actually, based on your needs, to develop or use any other third-party payload SDK. For example, like you can develop your own LiDAR sensor and oblique cameras, multispectral sensors, and hyperspectral sensor as well, to perform different aerial map missions. And one of the example is we have some partners, and they develop their LiDAR sensor under our matrice M210RTK V2, and to perform like LiDAR inspections for power line inspections, and cadastral surveys as well. And another example is the oblique cameras. There are some partners, and they develop their own like oblique cameras under our aircrafts. So it has the 5 sensor face different angles. So previously when we used P4RTK, so that needs to fly area 5 times to capturing the 3D the images for the 3D reconstructions. But now, by having the oblique cameras, you just need to fly 1 time, and that will greatly improve the efficiency. So this graph shows the time when we use the matrice M210RTK V2 with X7 camera, and the efficiency that is basically around like 26 to 27 minutes. And that's the efficiency of the matrice 200 series with different payloads. And also there are if we compare the matrice M210 RTK, M600 Pro, and P4RTK, and the different the drones, the efficiencies that they have. So for the P4RTK, when we look at if we want to capturing the aerial mission, the GSD under 5 centimeters, so per flight it can cover up to like 0.8 kilometer per square. Oblique missions for per flight, it's around like 15 kilometer per square. And all the drones are capable to achieve like GSD under 5 centimeter map mission job. And for P4RTK and matrice M210RTK V2 with X7 camera of the 24 and 35 lenses one, they can achieve the the precision map missions without GCP. And for other like M600 Pro, with the RTK, that can actually support less GCP for precision mapping as well. And the efficiency for the M210RTK and also the M600 Pro really depends on the camera, but in most cases, people will carry a large sensor under those aircrafts. So the efficiency per flight could easily above like 1 kilometer per square per flight if we're looking at a GSD under 5 centimeter, and easily above like 0.3 kilometer per square for the oblique missions as well. So in the last, it's, from DJI side, we only do the drones and the software that are associated with our aircrafts. And we're not able to finish all the end-to-end solutions. So we want to build our ecosystem as well. For example, like there are several scenarios, for example, like digitizing and corner lines and beam analysis and geospatial analysis, work with our partners to create more comprehensive and mature and efficient, whole workflow. Thank you. Thank you for participate today's webinar, and it's and if you guys have any questions, interest the products, feel free to contact our local partner competitors, and they are very professional, the partners, and to sell our products. And I think you can have received a great support from them as well. And thank you for your time, and stay healthy. Thank you.